Imagine a world where every sum, every multiplication, every complex calculation had to be done by hand. No machines, no digital tools, no shortcuts. Merchants, mathematicians, and scientists spent days, even weeks, solving problems that today take seconds. Then, one revolutionary invention changed everything. The first calculator. A machine that could take numbers, twist gears, and spit out answers, forever altering human progress. For as long as humans have traded, measured, and explored, numbers have been at the heart of civilization. Counting sheep, weighing grain, predicting celestial events, and building complex structures all depended on accurate calculations. Early humans used simple methods: pebbles, knotted strings, tally marks etched into bones or clay. These were primitive yet ingenious solutions to an age-old problem. The abacus emerged as one of the first true computing tools. Sliding beads on rods allowed humans to perform arithmetic efficiently, but it was still manual, requiring skill, concentration, and time. Every calculation had to be done carefully, with a real risk of human error. As societies grew more complex, the limitations of manual computation became painfully obvious. The idea of automating arithmetic had been floating in the minds of thinkers and inventors for centuries. In the early 17th century, Wilhelm Schickard, a German astronomer and mathematician, created what is now recognized as the first mechanical calculator, called the calculating clock. Schickard's device could add and subtract numbers using rotating gears and wheels. This was groundbreaking, a machine performing what humans had done for millennia by hand. Unfortunately, his invention was short-lived. A fire destroyed his workshop, and the calculating clock faded into obscurity, almost lost to history. Years later, Blaise Pascal, the French mathematician, invented the Pascaline in 1642. Designed to help his father with tax calculations, this mechanical calculator could add and subtract numbers automatically. It used a series of interlocking gears and dials, a marvel of engineering for its time. Though only a few were made, the Pascaline demonstrated the potential of machines to reduce human error and save time in arithmetic, laying the foundation for future computing. The story of the calculator's evolution continued with Gottfried Wilhelm Leibniz, a philosopher and mathematician who dreamt of a machine capable of multiplication and division, not just addition and subtraction. In 1672, he created the Stepped Reckoner, which could perform all four basic arithmetic operations using a clever step drum mechanism. While delicate and prone to mechanical failures, the Stepped Reckoner proved that even complex calculations could be mechanized, inspiring generations of inventors to refine and expand upon his ideas. The 18th and 19th centuries saw the rise of mechanical innovation as industrialization accelerated. As commerce, science, and engineering grew increasingly complex, the need for reliable, faster calculation devices became urgent. Enter Charles Babbage, the English mathematician often called the father of computing. Babbage's difference engine, conceived in the 1820s, was designed to compute polynomial functions accurately, solving hundreds of calculations automatically. Babbage's ideas were ambitious and ahead of their time, too complex to build fully with the technology available, but they laid the blueprint for all modern calculators and computers. At the same time, simple mechanical calculators became practical for daily use. The arithmometer, invented in the 1820s by Thomas de Colmar, allowed addition, subtraction, multiplication, and division in offices, banks, and engineering workshops. Hand-cranked, precise, and durable, these machines revolutionized the workflow of accountants and engineers. For the first time, human error in calculation could be minimized and laborious computations could be completed quickly. By the late 19th and early 20th centuries, the demand for speed and efficiency drove further innovations. Calculators became more compact, more accurate, and easier to operate. Machines like the Monroe calculator and Friden calculators allowed thousands of operations per hour, powered by hand cranks or electric motors. These devices became essential in offices, factories, and universities, marking a shift from manual to mechanized computation. The The mid-20th century marked a turning point. The integration of electricity with mechanical computation gave rise to electromechanical calculators. These machines used electric motors to power mechanical components, dramatically increasing speed and reducing effort. By the 1950s and 1960s, offices relied heavily on these machines for accounting, engineering, and scientific calculations. The age of industrialized calculation had arrived. Soon after, digital calculators appeared. Using transistors instead of mechanical gears, early digital calculators could perform arithmetic even faster, with unprecedented reliability. Portable versions arrived in the 1970s, small enough to fit in a pocket, transforming education, business, and personal computing. The calculator had evolved from a room-sized machine to a personal device, accessible to anyone. Yet, the calculator's impact goes far beyond convenience. It accelerated human progress, allowing for rapid innovation in engineering, architecture, finance, and science. It laid the groundwork for modern computers, programming, and even artificial intelligence. The principles first envisioned by Schickard, Pascal, and Babbage are still alive in every device that processes numbers, from your smartphone to the servers powering the internet. Calculators also democratized knowledge. Complex mathematics, once the domain of scholars and experts, became accessible to students, professionals, and anyone willing to learn. Problems that once seemed impossible could now be solved, opening the door to discoveries in physics, chemistry, and space exploration. Today, when we use digital calculators or spreadsheet software, it's easy to forget the centuries of innovation behind these tools. Every addition, subtraction, multiplication, or division we perform is part of a lineage stretching back to early mechanical gears, cranks, and wheels. The first calculator was more than a machine. It was a spark that ignited the human drive to simplify complexity, conquer time-consuming tasks, and unlock the full potential of numerical understanding. The next time you type a few numbers into a calculator or tap an app to solve a math problem, remember the ingenuity, patience, and vision behind that simple tool. From Schickard's calculating clock to Leibniz's Stepped Reckoner, from Babbage's difference engine to the pocket calculators of the 1970s, humans have always sought to turn numbers from a burden into a bridge. The first calculator wasn't just an invention. It was the beginning of humanity's journey toward mastering numbers, unlocking innovation, and reshaping the world. Today, every click, tap, or calculation is a tribute to the machines and minds that made counting, measuring, and computing faster, safer, and smarter.